Ever wondered how virtual characters or avatars move their faces so naturally when they speak? It's not just about matching the audio. It's about capturing the subtle, complex dance of our lips, cheeks, and tongues as we talk. Today, we're diving into a groundbreaking study that's making speech-driven 3D facial animations way more realistic. Let's start with the basics. Researchers created a dataset called VOCASET, which includes 480 facial motion sequences from 12 people. Each person spoke for about 4 seconds, recorded at 60 frames per second, like capturing every tiny twitch of their face. They also included 255 unique words and 5 sentences, all shared across speakers. Think of it as a rich library of human speech expressions. But here's the challenge. Existing models often struggle to translate audio into lifelike facial movements. Why? Because they treat every part of the face equally. Imagine trying to paint a portrait by applying the same brushstroke to every part of the canvas, no matter how different the features are. That's what current systems do with facial animations. Enter the phonetic context-aware loss, a smarter way to train these models. Instead of just matching pixels, this new approach focuses on how sounds influence each other. For example, when you say fa, your lips start open, then transition to the sound. The model now learns to prioritize these visemes, the visual shapes of sounds, based on their phonetic context. It's like giving the AI a roadmap of how our mouths actually move when we speak. Here's the magic. Traditional methods treat each frame of animation as an isolated event. But speech isn't a series of static poses, it's a continuous flow. Think of it like learning to ride a bike. You don't just memorize the position of your legs at a single moment. You learn how they transition between movements. This is called coarticulation, the way our facial muscles subtly adjust based on the sounds before and after. For example, say the word a in a crab versus a calico. The way your lips move isn't the same in both cases. In a crab, your lips close after the a, but in a calico, they stay wide open. These tiny shifts happen because each sound influences the next. Traditional models miss this, leading to jumpy, unnatural animations. The researchers solved this by creating a loss function that weights facial movements based on their phonetic neighbors. Imagine training a model to look ahead and look back as it generates animations. If a sound is influenced by the one before or after it, the model gives those transitions more attention. This leads to smoother, more realistic results. To test this, they replaced the traditional reconstruction loss, which focuses on pixel-level accuracy, in models like FaceFormer, CodeTalker, and ScanTalk with their new loss. The metrics. 4 key measures. 1. FVE, face vertex error, how far the generated face differs from the real one. 2. LVE, lip vertex error, focuses specifically on the lips. 3. Temporal smoothness, measures how fluid the transitions between frames are. 4. Perceptual quality, human evaluators rate the realism of the animations. The results. The new method outperformed traditional techniques across all metrics. Animations didn't just look more accurate, they felt human. The model's ability to account for coarticulation meant that even subtle shifts, like the slight puff of a cheek during a P sound or the rounding of lips for a W, were captured with precision. This matters for more than just movies and games. Lifelike avatars could revolutionize virtual communication, accessibility tools for speech-impaired individuals, and even therapeutic applications. Imagine a world where a digital assistant can express empathy through nuanced facial expressions, or where a VR character adapts its speaking style to match your own. So next time you watch a character speak, remember, it's not just about matching words to lips. It's about capturing the invisible dance of coarticulation that makes speech feel human.